Resin.
Photopolymer.
SLA.
DLP.
Expo. Hello everyone, welcome to the podcast called Expo. We will talk about 3D printing and today's topic are technologies SLA and DLP with my guest Jan Galko.
Hello, good to be here.
So let's start with the history. How did the SLA technology start?
Surprisingly, all the 3D technologies we know and use today started in 1980s, essentially. It might have something to do with the fact that all the 3D technologies are CAM, or computer-aided manufacturing, which requires computer. And in 1980s, it was a boom with personal computers and everything, so all these technologies are developed. But this particular technology is regarded as the first one, and the name connected to it is Chuck Hall. People may or may not know. Chuck Hall was working at the beginning of 1980s as in the company. I don't know if it was woodworking company or something, but they were essentially coating tabletops with UV curable resins. And so what Chuck thought was like, what if not a man was doing this, but a computer or a robot or some mechanism controlled by computer, and what if there was not a one layer but several layers, an object would be created like this. And so this was the basic idea for that. So he filed a patent for it. But as it happens, a French team actually filed the patent few months before him. But what happened there was a French team filed a patent, but they done their research on company time, essentially, and as such it was owned by company, and their boss simply didn't saw the potential for that patent to be profitable in the future, and he decided to pull the plug. So eventually the patent was attributed to Chuck, and Chuck saw the potential, and the year after the patent was granted to him in 1986, he introduces the first SLA printer, aptly named SLA-1.
Can you maybe describe how this technology works and maybe also differentiate between each printer?
Sure. So we can see, if we look at the Chuck's patents, we can see that he thought of several variants. So essentially, SLA is the umbrella term that would consist of several versions or several modifications maybe for that technology. So what it actually requires is UV curable resin, and to be cured by a computer-controlled UV source. This can be laser, this can be projector, or this can be LCD display. So let's get to particular examples. So most popular or most commonly known thing will be something like Anycubic or a Lago. What's happening there is essentially your printing substrate is coming up from your resin base, essentially. That resin base has see-through floor. Underneath that is a monochromatic LCD display that is then cured with LED matrix, essentially. There is a light source underneath the display, and the display essentially makes a negative of the layer that you currently printing, and the light gets through the display and exposes the parts that are then hardened, and the layer is created, and this process is repeated. This is cheap, effective way to build a 3D printer, and to use it and to maintain them. Problem then is maybe something like the LCD display loses its quality after time. So it loses its quality after, let's say, 2000, generally after 2000 printing hours. So relatively fast you have to replace it, or risk that your resin doesn't get as exposed as it should. Then there is, as we said, we can use laser to make your layer. So literally point after point with this laser making your layer. For example, something like this is used in Stratasys SLA, which is their version is called Neo. There are actually several machines under that. The largest one is 800 by 800 millimeters, so quite large. And the difference between these home or more affordable printers is that there is a pool of resin. Essentially, whole your print is submerged in the resin. So it's actually, laser comes from the top. It draws essentially your layer, and then layer drops down and is submerged deeper and deeper. And then after the print is finished, it has to go up and comes from the liquid.
What is this technology typically used for?
Well, all the 3D printing technologies are mainly used or were designed for prototyping or were conceived for prototyping. But obviously, since then, it has some development, and given that these resins are now developed that can pretty much have any physical properties you like there are resins that will that can handle 300 degrees Celsius temperatures, or resins that are high impact resins, like you can throw it against the wall and it will survive, or rubber-like resins or see-through resins. So you can pretty much simulate any physical property you want. And therefore, because of that, and because the precision, like compared to FDM, it's very precise, and the surface is very nice, especially if you have high resolution display. Like today you can find something like 16K display or something like that. It's very high resolution for relatively small area, and therefore the quality is quite astonishing.
So let's move on to the other technology, which is DLP. So how would you describe this one? How is it different from SLA?
Well, it's not actually different from SLA. SLA is, as we said at the beginning, it's an umbrella term, and DLP is part of that. Like, it's one variation of SLA technology. What's different is that instead of laser or LED matrix as a source of light, is used DLP projector. That's why DLP. And what's this about? Essentially, DLP projector can achieve higher luminosity, let's say. So because compared to laser, it's faster, because laser has to like go point by point, and this can go whole layer. But it's actually stronger source of light compared to those home-based printers where you have LCD display, because LCD display will take some energy from that light, and not whole energy is transferred to the substrate. So it's actually, it either allows you to print faster, or, well, it actually allows you also to print higher layers, because it can go through more of the liquid. And yeah, pretty much print faster and use more difficult materials. Like let's say because of this light source, companies like Henkel or Loctite develop their new materials with this printer because it can produce the energy they need to cure it properly and fast. So they develop it on that. Obviously, if it's open source, those materials can be used on any other printer, but this one seems to be more preferred by these companies for whatever reason.
So that's it for today. Thank you for your answers.
You're welcome. Anytime.
And I hope you liked it, and see you next time. Bye.
Bye.
Hello everyone. Well, how did the SLA technology originated? Origin. How did the SLA technology
Originated.
Jak to? Did? Tam mám.
Jsi povedla originate? Dobré.
Co je to slovo?
How did 3D printing technologies, how did this technology, a můžeš povedat started?
Že jo, já si myslím, že můžu říct start.